Hello, everyone. Welcome. How you all doing? Had a good first day of the conference so far? Yeah? Yeah, some good talks? Lovely. I've got a talk for you today. It's probably going to divide some opinion because some of you have experience with notebooks that will want to, that will probably make you hate some of what I'm going to say today. But please reserve your judgment because I think there's some interesting stuff that hopefully you can take back as part of your development work today or take to your business in some way. So yeah, reserve your judgment for a little bit. If you really hate notebooks, if you love notebooks, then you're in the right place. Today I'm going to talk about the marriage of notebooks and .NET. I'm a new face to NDC, so hello. My name is Alexander Hall. I go by the hilarious moniker of Look Mum No Handlebars, which is very funny to the 10 people that remember the Shoreditch bike shop that had this name. I work for a couple of, or have worked for a couple of multicolored logo companies, currently work for Fund Apps, and I generally work in .NET and TypeScript. But I'd like to start with a little bit of a hypothetical situation. So you start a new job. On your very first day, if you're lucky and the IT's all sorted out for you, what you might experience is the chance to get to know the code a little bit. You'll get some onboarding. You'll start to go through maybe some of the diagrams, the architecture diagrams, figuring out the system a little bit. And you will maybe hit a point, depending on your business, that there's this big opaque box in the middle of these diagrams that says ML app, or this is where the ML code is. And you ask about it to a fellow developer, and they say, oh yeah, that's the ML team's job, that's the machine learning team's job, that's the data science team's job. Don't worry about that, we just consume it. Just out of interest, hands up, has anyone experienced that here at work at all? A little bit. I've got one hand here, one hand at the back. Lovely. Cool. So it can happen. I will say, I run quite a lot of interviews, especially at the junior and mid-level, and what they tend to describe is basically this in some sort of different format depending on the business, which is some sort of data pipeline in, whether or not it's scrapers or some form of ingested data, and then it enters this big abstract ML AI pipeline in the middle, which they can't really talk to me about in the interview. They just say, oh yeah, that's the ML team's problem, and then we consume it on the back end. That is shockingly common, I will tell you, at the moment in junior and mid-level interviews. Out of interest, how many of you, when you use or when you go to do ML or AI, either at your business or in any of your personal work, jump to using Python? Can I get hands up if you primarily use Python for ML and AI? Okay, a few hands up, yeah. Cool, lovely. So it tends to be, for that exact reason, that those two things are split off. A lot of the ML AI tooling is designed around Python, whether or not it's Apache Spark, TensorFlow, Pandas, any of the traditional libraries that people might be familiar with. And then on the back end, where you get back-end developers working and consuming some of the stuff from the ML and AI work, tends to be a whole different architecture stack, whether or not it's .NET, Node, Go, Rust, anything. It just tends to be how the business evolves. And it always kind of makes me think a little bit of this meme, which is everything the light touches is our code. But what's that shadowy place over there? That's the ML application symbol. You must never go there. That's sometimes how it feels a little bit to me anyway. So why does Python own the AI and ML tech stack? Hopefully you would have figured this bit out, given the title of the talk. A big part of it is the Jupyter Notebook. Jupyter Notebooks appeared around 2014, and they just became a really useful way for mostly data scientists and ML engineers to essentially try little bits of code out, document their code as they went along in Markdown, run discrete cells, and store the state in a kernel. So you can run code, the kernel will store the state and make it transfer between different cells. And of course, alongside that, you get the more well-known stuff with Jupyter Notebooks, which is they're pretty. You get actual clear visible output rendered, you can build animations, you can build whatever you want, pretty much as long as it will render in Markdown or HTML. And the stats behind it making Python popular are pretty alarming, actually. If you go back to 2014, roughly there on the diagram, and chart when Python rose from 4th on the popularity list on GitHub all the way up to 1st, you can see it's very much correlated, maybe not caused, but correlated with 1.5 million Jupyter Notebooks on GitHub. So like it or not, Python sort of took over that market, and it's very much an important reason of why Python became very, very popular. And Michelle Winters, formerly of Netflix, now working for eBay, wrote in the Netflix tech blog when she was writing about this stuff in 2018, talking about how Netflix kind of evolved. Wrote this kind of very neat quote that shows how notebooks became not just like a side part of their infrastructure. It was very much core and critical to the way Netflix are making their decisions, right? They are taking all the data that users are giving them, including things like clicks, how far they need to buffer in across the stream, how far users are going to skip to make sort of buffering a less painful experience potentially for users. And then they feed all of that into data lakes, data warehouses, and then they have notebooks that essentially are fed around, the number given there is 100 petabytes of data on scheduled jobs, and it's become a core part of their infrastructure. So they're not just for experimentation, they can be a very core part of basically a business operation. Some of you will know this and you'll understand this as a part of your business. My business at the moment doesn't have anything like anything like this. We probably will soon, but just important to know how critical notebooks can be. Now, the reason I'm talking about .NET today, and have mentioned Python about 50 times already, is Python kind of got there first. Python in 2014 got the Jupyter Notebook. In 2001, they got interactive Python as well, IPy, and they had problems with them, both of those technologies, but essentially they enabled people to create interactive code. Both of those programs, whereas .NET in 2014 still wasn't cross-platform and took a long time to catch up. So we didn't really get .NET interactive code at all or anything that looked like notebooks until around 2019, and then really 2021, 2022 until it became sort of mature enough to work with. And by that point, Python had already run away with the market, basically. However, a little bit like the tortoise and the hare, my argument today is kind of that .NET is catching up and maybe even overtaking it. One member of the audience said to me earlier that people might come to this talk just to tell me off for even bothering to talk about Jupyter Notebooks because you've had such a bad experience with them. The premise of what I'm going to talk to you about today is a little bit that .NET has not just overtaken, but improved the notebook and actually made it a better experience to work with altogether. But I still got excited the first time I saw .NET was actually available in a Jupyter Notebook, because normally it's Python, Julia, and R, and it's actually not that much work to get a .NET notebook up and running. And so this is what we're going to talk about today. We're going to talk about how notebooks make .NET interactive. Notebooks can make your .NET life better. .NET has actually extended the Jupyter Notebook, and how .NET can actually look for potential ML and AI applications. So first up, I want to talk a little bit about how how notebooks have made .NET interactive. Now, when I say .NET and notebooks, really this is the technology that underlies that. So it's a very simple two-line command, just install the global tool of .NET Interactive and install Jupyter kernel. You can then just have access to it in any Jupyter environment running locally, or similarly if you're working on compute or something in the cloud, this works the same way. You can just install the kernel, install Jupyter Notebooks, install .NET Interactive, sorry, and it will be there for you. The .NET kernel, however, which we're going to talk a bit about today, comes with a few interesting problems, because .NET isn't just C#. I'm talking mostly about C# today, but it is actually C#, F#, PowerShell. They've kind of ignored Visual Basic at this point, but still, point being, in an ideal world, they want to be able to run multiple or run different languages very easily. So the way it works and the way the Jupyter kernel works on its own, and .NET Interactive works, is it's all behind this composite kernel. It looks a little bit like event-driven code, right? You're submitting code with what language it is. The kernel will then process it, and whether or not you just have it as a command or whether it returns a value, you'll get an event back, and command succeeded, command failed, depending on, and that's kind of how the system knows how to deal with it. Now, one of the other reasons that Python got there first is writing a REPL in Python is much, much easier than writing a REPL in .NET. If any of you have ever tried, it's surprisingly difficult to do, because .NET is compiled and Python is interpreted. So all you need in Python is the eval function. However, what .NET Interactive does, and what that package really is doing under that hood, is this code. It's just making a simple C# kernel. Under the hood, that's Roslyn. That is the same technology that you are using for code formatters, for analyzers in your IDE. It's the same kind of on-the-fly technology that is underpinning the C# kernel. And you just submit the code, send async, and you can handle the events coming back from the kernel. In F#, it's pretty similar, but F# has F# Interactive, so it's a slightly different technology. And that means you can do crazy things like this, which is basically create a kernel, put it behind a submit endpoint, and then suddenly I've made my own version of Jupyter Notebooks anyway, and we don't need to worry about Jupyter Notebooks for the rest of this talk. I'm kidding. But the point is, you can basically make all of this stuff yourself pretty simply. The technology is really, really not that complicated. And in this example, all I'm doing is sending simple computation to the REST API with just behind a submit endpoint, only a few lines of code, and it will run the example. Now, .NET Interactive as a package underlies quite a few different technologies that you may like, not know about yet. So first off is the .NET REPL. So same technology. You can use the command line to create code in your command line and run it. Now, it's not that great. It works for what it is. I would hate anyone telling me that C# should be run or created generally in the speaking in the command line. However, on a similar kind of wavelength is .NET Script. Any of you use CSX files at all? C# script files? Anyone? No? Is that new to everyone in here? One person in the back, yeah. So if you just wanted to run a single C# file as a script, you can run .NET Script. Check that out after the talk. It's a really useful little way of having single executable scripts that look a little bit like the notebooks we're looking at today. And that's underpinned by the same technology. Try.NET, which is a little bit like the REST API we were looking at before, is now, sadly, as of about a month ago, been deprecated, but can be used. You can just, in the same way, run scripts from the browser. When you're using IDEs, Visual Studio or Rider, it's the same technology if you want to do interactive programming while you're debugging, so i.e. running code with variables in your debug state. And finally, the one we're going to talk about today is Polyglot Notebooks, which is sort of VS Code's interpretation of Jupyter Notebooks. And why I'm focusing mostly on notebooks for this talk, out of any of those, is notebooks give us three very, very key things. Quick visual feedback, so I can see quick outputs from my code. I don't have to run a whole program.cs to get just very quick feedback on little lines of code. And that in turn leads to interactivity and experimentation. I can play around with little modules of code and very easily change one thing, not break the compiler everywhere else, and just play around a little bit more than I would naturally when writing code. Makes it great for testing out ideas. And then finally, and probably the key why data scientists use notebooks, is you get presentable code. I don't necessarily have to go create a whole presentation for my business. If I wanted to make some points about the data analytics that I've got back for certain bits of data that I want to present back, then I can just give it in a really neat form of a graph, something rendered anyway in HTML, because notebooks are just HTML. And it's a really neat way of sort of showing through code people who do not know much about code really useful things. And yeah, so the main technology which I'm going to be working with today is Polyglot Notebooks. Polyglot Notebooks are an extension of Jupyter Notebooks. I'll talk a little bit about what that means later, but essentially they work with Jupyter as well as with .NET in a slightly interesting way. And notebooks, the reason we want notebooks in our sort of .NET ecosystem is we get all of these things essentially bundled as part of that. We get the ability to do machine learning. We did have that a little bit already, but now we can experiment a lot more. We get data science. We get ability to test out AI models much more easily. We get disaster recovery, which I'll talk about later. We get documentation. We get the ability to teach a little bit easier than having to write whole programs. We get the chance to experiment. And all of those are very rich features to have as part of a language's ecosystem. And then there's the philosophical kind of point. cards on the table, I am both a programmer and a musician. I kind of split my time a little bit. And I will tell you, as someone that writes relatively frequently for choirs and orchestras, that if you try and write a whole piece of music, essentially just going, I'm just going to write all of this, you will fail and you will end up trying to write music at 1 o'clock in the morning, not speaking from experience. But the right way, or one of the best ways to compose music as you go along, is to sketch. Is to just write down little sketches, little ideas, play it out on the piano, or sing it or whatever, put it in Logic, put it in Cubase, whatever, however you want to do it. Just put down these little snippets so you can try it out. It's the same kind of philosophy here with coding. So notebooks, while they are a tool, also a little bit of a philosophy with how you approach code as well. And the same kind of philosophy applies for artists, right? Artists will always sketch things out to the nth degree, always maybe a bit hyperbole, but they will sketch things out heavily before committing to canvas because the paint on the canvas is expensive. Same with Pixar, right? When they're making animations, they will sketch out the simple, easy stuff first so they can change their mind before committing to the expensive animation. So you can use the same kind of theory for notebooks, right? You can use them in the same way, potentially sketching out ideas as opposed to jumping into complex solutions. I might just read this quote from Martin Fowler. So, when I'm exploring some data, it's useful to keep my notes close together with the code that performs the exploration. I like to try some code, look at the results, and note down any observations I have from that execution. A computational notebook allows me to combine these together easily in a single document, which kind of is the mission statement, I think, for notebooks a little bit. Lovely. So that's the kind of précis, a little bit about how we got interactive notebooks in .NET. I want to talk a little bit, maybe for the reason you're here today, how notebooks can make your .NET life better, potentially some things you can take back to your own development life. I broadly categorize these in 4 areas, and we'll start with sandboxes. So, a little bit of a story from me. Around 4 years ago, when I was a junior going on mid-developer, I was tasked with carving out a part of my monolith, or our monolith in the business, and going and making a microservice with a clear bounded context, an API, a nice SDK, opinionated SDK as a client, so that we could call that from our monolith, as well as call that from other services which didn't want to know about the monolith. Which we did. And I created some of these examples so that any of the other developers in my team, or generally speaking across the business, or cross-pillar, or any other of the topology that is appropriate, I created this program.cs that essentially that had all of the examples for my opinionated client. And this is a much simpler version of what it looked like. I thought this was good at the time. I don't now. But essentially, this was a provided program.cs that they could run, and I would say, uncomment to test different requests. You can test this, you can test that. It's very clunky. I think it's very, very clunky today, looking back at it. Some of the developers in my workplace really loved it because it meant they could try stuff out, but I look back at it now going, there's a much easier solution to that. And that much easier solution is doing the same thing with notebooks. So I now don't have to comment or uncomment anything. I can, at the very top of my notebook, create the setup, and I can expose different methods in different blocks, and you can then just test them out one by one. You don't need to edit anything, you don't need to change anything, and most importantly, you can just change the single block of code, again, without breaking the compilation anywhere else, which is pretty neat. It's not just me doing this kind of stuff. Reactor, i.e. the reactive library, also use this kind of technology for some of their documentation. So they have .NET notebooks for their getting started. And as you can see, you can potentially do things like attach debuggers and things like that and step through the library in a notebook. This gets pretty powerful when you're working with code that you don't know, especially. I'm going to walk you through a little bit of that now. Lovely. First of all, is that clear to everyone? Lovely, thank you. Cool, so this is a little bit of a sandbox that I've built for an open source library that I've been working on, a very simple open source library called Soap on a Scope. Hilarious, I know, but it's meant to be just a simple sanitizer for requests, i.e. you take in some strings that you don't know whether or not they've been properly sanitized from the front end, or generally speaking, from the producer, and you just put in a safe sanitization on top of it. Now, I built this documentation originally for that library, and what you can see is that I can potentially split out local and NuGet package versions as well, so I could run against the NuGet package if I wanted to. As it is, I'll just run locally, and all this is doing is very simply adding in the DLL, adding in the using statement, and using the built project, and that's as simple as it is to bring in local libraries. I can then document every single thing I want my user to try out. In this case, I've got a trim and an auto-trim attribute at the very top of my class. And I can, let's hit play here, see what happens. Lovely. So you can see that in the way this code works now, that original request, the auto-trimmed request, has got all the strings trimmed. If I wanted to play around with that and say, OK, well, what happens if I add an X there? It's going to say XSS, that's wrong. Now you can see that that only works at the very start, but we still get the space maintained. And I can try that around various different ways. And similarly, I've got the trim method here, which doesn't do inner nested things. So I can see that then the spaces are maintained on the other one. I can do that for every single exposed kind of method, exposed part of my API that I want developers to be interacting with, and they can try it out. I would highly recommend this for building out open source documentation, building out libraries that you want your team to use or want other people in your business to use, because it is so interactive and such an easy way to play around with code. Lovely. All right, let's talk a little bit about teaching. So with interactivity comes the ability to kind of, as I've already hinted at, play around with code. And it means that for relatively complex concepts, you can create discrete code and discrete blocks of code that you can then basically play around with, prove points to students, give clear, visible outputs of what is happening in your code and why. And there are three kind of potentially useful cases for this. So first one, I'm sure most of you know who Nick Chapsas is. You'll notice that in his videos, he always uses a program.cs, often comments things, uncomments things, doesn't keep track of the, or has to delete things to make the compiler work. And that's fine. It totally works for him. But in your own work, it might be worth exploring trying to use notebooks in this kind of way, because you can build these kind of interactive slides as you go along and small snippets of code to run. Similarly, if you're running workshops, the code I'm about to show you in a little bit of the GIF you just saw was me building out basically a concurrency lecture or a concurrency talk for engineering week at my company FundApps, because we have a lot of junior and mid developers, some of which have transferred into coding, a little bit like myself, and they don't know naturally how to use some of the more complex concurrency stuff that we need to know about as part of our job. So I built that as a kind of primer to be able to do that. Now I've just given my team a full way to, or a checked-in resource into a repository that they can come back to, play with as they need, and that's become a really useful tool for them actually writing performant code. So it might seem like a small thing, but it can become very useful. Similarly, if you wanted to do an NDC talk yourself, you could potentially do it all using notebooks. Jupyter comes with slides capabilities as well, so you can just separate it off into slides. So I'm going to get a little bit meta now, if I may, and show you my teaching materials. So similarly here, I've just got an init.csx, which is doing just bring in all the packages I need here. And then if I was teaching, or I might do this as a little, do you mind me getting a little bit meta? I'll teach a little bit as if I was teaching the junior developers. I hope you won't take that as an insult, but I will go into teaching phase, OK? So who here knows much about concurrency, yeah? Do you know, let's take this as an example, right? So here's a method called wait 1 second, then give me a value. Very subtle, I know. However, all this does is basically print a value that you give it, wait for a second, and return a value. This could be something computationally expensive, like going out to a third-party API or doing some serious data work, anything that basically takes time. This is a placeholder for that. If we run it, we get what we expect, which is the value printed, and it takes roughly 1 second. But the moment we have to add iteration into this, So if you're just using a for each, you might think that's the obvious thing to do. The obvious output is we're going to get 5 seconds. I will stop teaching you because you probably already know this, but you get the idea, is that I can very clearly show with outputs what the code is doing. And on top of that, for the rest of this, I can walk through all of the rest of the libraries, no matter what it is, and you'll see a few of them in a moment, and talk about the pros and cons, show very clearly in code when to use different libraries for different purposes, even though they're around the same context. So for example, I've got task.when all here. And that will show everything you need, but I can very clearly say that that's going to be a problem probably in production code because you've got no control over the degree of parallelism. So you have to talk about semaphores, all the rest of it. That can all be in different examples, but that is already a very powerful tool. And I can talk about why plink and plink has similar problems. I can talk about how to use the parallel library, data flow, channels, all the rest of them, and they all just work and show you very clearly, if I was to play any one of these, it works the same way and just gives a very clear output that I can then use for my junior and mid developers. Cool. Let's talk a little bit about runbooks. Runbooks are a kind of overloaded term, I think, depending on what software you use or what third-party tool you use. When I'm saying runbooks, I generally mean these kind of operations, so one-off operations. I can't be bothered to automate it. My business won't give me the time to automate it, so I'm just going to put one quick runbook together. If you're anything like me, or someone like me, then what you will have had is a lot of DevOps helper scripts written for you over the years, written in Bash and PowerShell that you can run in a panic, and then you try and figure out what's going on, and it's all a bit panicky, especially late at night when you're woken up on call. And that kind of falls under the bracket of disaster recovery a little bit. But you can also use runbooks for security and for data analysis as well. Just any of these kind of one-off operations where you want to sort of do something but not repeat it. Most of you will probably know this, as I've just kind of hinted at it. Runbooks in disaster recovery look a little bit like this. Failure detected, hopefully we'll have some sort of automatic recovery. If not, try and have automatic recovery, but for another day. Then, if it's late at night, you panic, use the helper script that you think exists, or go from some sort of wiki, and then run that helper script. I cannot tell you how much bad experience I've had with that over the years. I don't know about any of you, but I will curse a few scripts that have been written in saying, oh, this will never happen, because they're quite hard to read, especially if you don't regularly work with PowerShell or some of the more complex bits of PowerShell or Bash. However, with disaster recovery in notebooks, this is an example of like an EC2 recovery where you've got stopped instances of an EC2, a stopped instance of an EC2 container, and you can check the health, you can validate responses very clearly coming back from it. You can do all of the stuff that you basically want to do to recover and validate at each step. So you're no longer writing kind of half-baked CLIs in PowerShell. You've now got the chance to kind of interactively play around a little bit with it. So I'll give you a quick example of this. Let me shut this down. So under the hood here, just while this is starting up, all that's going on is as I'm doing a local version of this, I'm composing up local stack for AWS and SQL Server. One of the cool things that .NET Interactive offers out of the hood is a lot of extensions that can work with SQL Server, Postgres, SQLite, basically a lot of the more commonly used databases. And you can just plug in a connection string and work with the databases. Some of you who've used Azure Studio will know this Azure Data Studio will know this off by heart, but it's still a pretty cool thing because it's not so easy to do this in standard Jupyter Notebooks. And as you can see, I've seeded my database, and I can now have a little go with a runbook. In this case, I want to just query the database directly because it's easier than trying to use other code. So I can get, in this fictional scenario, we've got some sort of order that's been processed and is now incomplete in some kind of way. And I can check against my database and see there's a failed entry. OK, well, there's a failed entry. So in this case, for whatever my business wants or however my system works, I can just simply put an object in S3, and there'll be an event trigger off the back of it that will sort everything out for me. And that will just simply work. But it might be that you need to validate that. If there's nothing there, there's no point in trying to redo the S3 part of this. So if you only wanted to deal with incomplete orders, i.e. where your status might be hanging, it's just processing, it didn't fail cleanly, something in the process went wrong very seriously, you can run something here that will check a different part of why something might fail. And then let's say this part of the business, this part of the system goes away to SNS and sends a topic and just restarts everything because it thinks, oh, I haven't actually failed yet. I can now just re-kick off the process. Any of this kind of event-driven stuff where you can just resend the event, potentially. And then you've got that particular case covered. And you can do this. This is a very simple example for the purposes of this talk. But what you can do is create quite branching paths without the need for several if statements in code, without the need to sort of check things manually, but not in the code. You can validate each step of your disaster recovery, which can be, speaking from experience as someone who worked on a support team for 18 months, very useful. Finally, let's talk a little bit about data science. When I refer to data science, I'm broadly talking about these collection of operations. So collection, preparation, input processing, and output and interpretation. This is definitely something that is traditionally done with Python. Most of the data engineers you'll meet in various different guises will be using Python. And the reason to use Python is because you get these lovely visuals, as I've kind of already hinted at. You get very nice diagrams that you can take back to your business, make concrete business points, all from within the bounds of code. I don't know how many of you watch Heated Rivalry and whether this is a dated reference, but we're going to go with it anyway. However, what we're going to talk about a little bit for this example is ice hockey. So let me clear all the outputs. And I'll just init everything. So here I have a big old data set, standard CSV. This is the 24-25 season, all NHL players for every team, and a whole bunch of data points surrounding those players. So each team, their names, how much they earn, their annual contract value, AAV here, how many goals they've scored, those kind of things. This is the kind of data that actual professional organizations will be working with. Now, let me scroll down a bit. So I'm using here the native Microsoft data analysis library. And as you can see, for those of you who've used pandas before, this looks really similar. It is just the data frame, right? Which means that I can load up my data. It's all there. It's all in a nice little table for me. And I can start working with it. So one of the next things I can do is I can clean and process my data. In this case, there's one very obvious thing I need to do for this particular column. Anyone know what it is? What's going to be the problem here if I try and turn this into a number? Very simply. Say again? Yes. Yeah, exactly. Well, yes. It's a string, it's a $, and there's commas in between, which means that if you try to do int.parse, there's going to be problems. So one of the first things I need to do is take that and make it a number that we can actually operate averages on. So in this case, small bit of C# code here also, but that just cleans up this column, and now I've got numbers in my AAV column so that I know how much each player earns per year. And on top of that, I can then perform some basic analysis, right? So very simply, with just some mean and median functions, I can get the average NHL player age. I can get the average contract value across all players in the NHL in this case. I could group data, as you'll see in a moment, to make that more meaningful, potentially by organization. But it's the same principle. And then for this case, I might want to find out how much, or what's the ratio of goals scored to how much we're actually paying the players. You probably will care about this if you're a professional sports organization to figure out whether or not your money is going to good use. So I can create the data here, group by goals, and then mean the annual contract value. And then, as we talked about, I kind of want to turn this into a really nice diagram or some sort of chart that can be shown back to the rest of my business in a useful way. And I'm just using plotly.net here, which is a kind of port of the plotly library in Python. Not too complicated, and I can very easily just build up a nice chart. And that gives me some visualization of the data, right? Now, there's plenty of ways to interpret this data. Like, I'm going to imagine that this data point probably, slightly by design, is data that is not correct, because if we're paying an average of 4.38 million for 38 goals, I can tell you as an NHL fan that's not very likely. they tend to ask for a bit more money than that. But it is possible with rookie contracts. But the point is we can now work a little bit with that data, validate it, give it to various people if we want to make some business decisions off the back of it. So that's a kind of primer to how you can use data science in .NET in notebooks. And that's just scratching the surface. There are other cool things you can do here. If you really wanted, you can run an HTTP server in a notebook. I don't know why you'd do it, but you could. There are potentially ways to extend it beyond what I'm going to talk about today that I would encourage you to research if it's your thing. Lovely. Let's talk a little bit, maybe the more exciting bit for some of you today is actually how .NET didn't just didn't just say we're going to create a Jupyter kernel. They extended the Jupyter Notebook and made it slightly better than it was. First way they did that was with extensions. You've actually seen an extension or two already in some of these examples. So first one is a little table, and all that is under the hood is just a little extension I wrote that cleanly formats the table. There is some stuff that comes out of the box for this in Polyglot Notebooks. However, let's say I wanted to create something that was sort of in with my business format or looked nice as a table when I'm presenting it back to my business. You can write your own extension, and they're really not that complicated. I'll just show you very quickly the extension under the hood. This is the code I was showing you, which is that you register for each type. So when you're just outputting a type from the cell, it will match to one of the formatters that you've got. Otherwise, it will just output some form of JSON normally. And all I've done then is just create a little bit of C# HTML stuff with pocket views to map the table data or the data frame data into a table. It's really not that complicated. And then to make an extension, it's as simple as doing this, which is just loading up a kernel, exposing your load method, passing in the kernel, and then it will just work. So it's really not very complicated to make your own extensions if you wanted to. You can bring your own kernel. So this comes in two forms. Every Jupyter Notebook kernel will work out of the box with Polyglot Notebooks, which means anything potentially like, I don't know, Dino is the example there, but also Python. Anything with a Jupyter kernel will work as long as you can connect to it and have it installed. You can also declare your own kernels. You might be thinking, what's the point in this? But there's plenty of examples. So if you're using a complicated database, like potentially you could do this with graph databases, right? You could create a graph database running locally and then connect to it with your own kernel. You don't need to wait for Microsoft or the .NET team to create this for you. You can just build it yourself if that's important to your business. One of the sort of weirder use cases we have at FundApps is, which I'm working on at the moment, is we have our own programming language that we expose to a different part of our business. It's called the rules engine or the rules language. It's very similar to the Microsoft rules stuff if you've ever seen that. But it interacts with C#, and I can create a way to have developer-written code in C# that then works with a kernel that they can use with the programming language that that particular team are used to, i.e. creating the rules for the rest of the business, which is part of like a content team. So there are plenty of potential use cases for declaring your own kernel. One of the other really, really cool things is notebooks, these notebooks at least, are multi-language. I've kind of hinted at this a little bit, but when I say extended, if you were to try doing this stuff with a Jupyter Notebook, Jupyter Notebooks are single kernel only. You can just use one. It's very hard to use anything else if you've ever tried. I think it might be possible, but really they are just built so that once you're in a Python kernel, you're in a Python kernel, and that's it. In Polyglot Notebooks, in the VS Code notebooks, you can not only use pretty much any language you want in different cells, including the bring your own kernel stuff I was just talking about, but you can share variables. You can take variables from C#, F#, and plug them into Python, which means that you don't just have the .NET libraries that I've been showing you today as kind of ports. You can potentially use Python libraries or JavaScript libraries that someone else in your business is more comfortable with, just port over the variables between the cells, and it will just work. Now, with that particular last one, the reason that that happened is kind of interesting. So .NET, as I mentioned, obviously they want to be able to run C#, F#, and PowerShell potentially in the same kernel. You've seen reasons why that's quite useful today, because you can run Docker Compose and then just run C# code. They want to be able to do this all from one composite kernel as opposed to separate different kernels and one notebook at a time. So they kind of reinvented the Python notebook. If you've ever tried this, if you just change IPyNB into .json, you can see what's actually under the hood of a notebook. Notebooks are just JSON under the hood, which makes them seem incredibly simple. For Markdown, that looks a little bit like this. They're very, very simple. Just a very simple cell type, declaring Markdown and then source. There's nothing else really to add to Markdown. When you get to code, on the left-hand side, with Python, it just declares code, and you can only really use Python. However, with Polyglot Notebooks and C#, what you can do is just declare the kernel name. What happens is you declare the kernel name, and you can change the kernel per cell. And the reason that's allowed is because of a little metadata thing at the bottom of the JSON, where you just get Python or the version of Python in Jupyter. However, in .NET, you can declare multiple kernels, and that's how that kind of all works together. This is the traditional architecture. And from left to right, if I'm coming through a Jupyter UI, I'm going into the server. 0MQ then talks to a Python kernel and send messages back, a little bit like what we've already seen. The JSON file then just acts as a kind of intermediate store, and then everything gets rendered back to the UI. Very simple. In Polyglot Notebooks, all that happens is we just extend the ability to, instead of talking to one kernel, we can talk to multiple. We can go off to Jupyter that's using 0MQ. We can go off to .NET, which is just running in memory, and potentially anything else we want. Here's the complicated diagram that Microsoft produced for that. I'll talk you a tiny bit through it. Basically, you have potential front ends that can deal with the responses, which we've seen a lot of today. That can come in as either Polyglot Messaging Protocol, PMP, Jupyter Messaging Protocol, JMP. At first, it tries to talk to .NET Interactive. It will have a special metadata with it that says C#, F#, something like that. If it recognizes that, it will go straight to one of the kernels that it recognizes in the composite kernel. Otherwise, it will try and go out. So if you're using Jupyter, it will connect out to Jupyter using the Jupyter Messaging Protocol. And because the JSON is the same or just extended, it can just take the same messages and take the same JSON out. It will just only use what it needs. Otherwise, you can talk to your own kernels. You can talk to JavaScript. And as you've already seen, you can talk out to SQL tools. This is pretty cool, I think, because it wildly extends what notebooks are actually capable of. Cool. Let's finish the talk a little bit with .NET Notebooks for ML and AI. So, maybe the key question for today. Can .NET be a viable option for production ML and AI? Who thinks it can be? Yeah? Is that from experience? Or just yeah, well, you've talked for 45 minutes, it's probably possible. Anyone got experience of ML or using any of the ML.NET stuff for the site, anything C# related in production level ML or AI code? Anyone here? No, okay, that's interesting. So as I kind of said at the top of the talk, I think a big reason for companies not trying this is because of the lack of support on notebooks, because the majority of people who will be designing this stuff, training models, trying things out, will be people who are who natively write Python, basically. And it goes back to that same problem that I talked at the top. I started with at the top of the talk. So the technology stacks are so wildly different that they end up split up a little bit. And that causes a fair few problems that may or may not affect you in your business. Generally speaking, that comes across in two ways. That is cognitive load and specialism silos. Cognitive load, you've got multiple languages, multiple tech stacks. You've sort of then got double the amount, potentially, of tech stacks that you would naturally, trying to support two different ways of doing things. Bearing in mind, most programming languages are capable of the same things anyway. You've got an entirely different set of dev tools, and then you've got complex systems built on top of those dev tools that if you are a back-end developer potentially working with them, and again, something goes wrong late at night, you won't know how to deal with it. And that can lead to increased incident response times, potentially. So something goes wrong late at night, something potentially is wrong with the model that is causing serious business problems. In finance, that can be a very real situation. It means that then that will take longer to resolve. It means that you've got developer overhead, because you now have to have not only developers that know your back-end technology, you'll potentially need to have developers that can facilitate what your data scientists need and what your ML team needs, as well as your machine learning engineers and anything else along those lines on data science engineers. You've got much more potential money spent on just developers. And on top of that, increased time to value. And the reason I say increased time to value is because potentially if you're a small agile team, you then need to go and learn a whole new thing if you want to work with the ML stuff in some way. Let's say some of the ML team go out of your business. It means it's going to take much, much longer to actually bring something to market, bring value to market. And so I think this is the neatest, most contemporary way I can put this. Most of what I have discovered through my work with notebooks is that everything you think is better in Python may be better in Python, but it is very doable in .NET if it serves your business needs. Most of it is just finding the upside-down equivalent. So where you're familiar with pandas maybe or scikit-learn, ML.NET can do a lot of that. Similarly, Apache Spark, which is commonly used, .NET has the actual Microsoft team have developed a Spark library so that it's very easy to use Apache Spark with .NET. Similarly, NumPy and MathNet numerics, there's a lot of crossover, and they're not, once you get to learn the libraries, they are not that difficult to use. So I'll give you a little bit of an example of how ML looks in notebooks, and you'll see it's not too dissimilar to how it looks in Python notebooks either. Cool. So as before, nice simple setup. In this case, I'm going to start by just training my data. So in this case, it's a really simple data set. I've made this deliberately simple so that you can observe just how it's going to work. In this case, it's just a size of a house, the square footage of a house, and the comparative price of the house. And we want to be able to tell from the size of the house potentially how much it might cost. So in this case, I'm just going to load in a data frame. And then I can create a little pipeline. All this pipeline is doing, even though it's got some scary, scary consonants mashed together, this is just a linear regression pipeline. So all we're doing is creating a linear regression relationship between the size and the price, and then finding the fit for the model. So now we have a model. This is where we come into the next part of ML work, which is testing that you've actually got the right model. In this case, I've added a test data. Traditionally, your test data will be data that you know is more accurate so that you can tell whether or not the coefficient is actually correct. And in this case, this little bit of code is going to do that. So I've got my training test data you just saw. I'm going to transform it using the model that we've created, or evaluate against the regression, and then just determine that this will output a coefficient, which will be somewhere between 0 and 1. If it's close to 1, generally means that our model's pretty good, and we've got a good model to use. In this case, lovely, it's 0.98, so it's going to be pretty accurate when we try and predict off the back of it, which is what we're going to do next. So we want to figure out the size of the house. If we just get a size, if we have a house given to us and it has a square footage, what's the most likely price that it will be, or what's the most accurate price that we can give it? So we create a prediction engine, and then very simply run the prediction engine. So for 2,500 square feet, 274K. I know we're in London, and that's a ridiculous proposal as engine, but promise to someone that looks at house prices occasionally. But in the context of the data, that actually is very, very simple. And you can see it's really not very many lines of code, and it doesn't look that dissimilar to what people are used to in Python. And then if I wanted to export and save the model that I've created, in real life, this would be with a lot more data and a much bigger model. But the same thing applies. I can just save it to a zip. In a real pipeline, I'd then save this to S3, and I can then consume that model from other parts of my application. The thing I also wanted to just mention at the end here is since ML.NET has got a little bit more mature, it's much easier to work with and actually has a lot of extensibility. In the Python libraries, you can kind of fluently declare different backends, for those of you who've tried out the Python libraries. There's some similar functionality in ML.NET now, so if you wanted to use TensorFlow, you can. There are ways to plug in TensorFlow into ML.NET. Scikit-Sharp also have their own TensorFlow.NET library, which you can use instead of all this. So there's multiple options here. If ever you want to find out more of this stuff and get some different examples that are a little bit more complicated, do check out that particular repo, the machine learning samples repo from the .NET team. However, as much as I've talked about them today, ML and AI applications are not just notebooks. That's a big part of it, but they are not just notebooks. They're a complex web of things that you then need to do with those notebooks. This is Netflix's infrastructure from about 2018 again. As you can see, it's very, very complicated. Interact, in this case, is just another a tool for notebooks, but that goes off to, that gets scheduled, so they'll run this on a schedule for each new potential show, or as the user base grows, they might want to add to the data set. And they will do a bunch of calculations and train their models and store them off in S3. They also need to feed that with some sort of big data warehouse or data lake as well, i.e. getting schemaless data and being able to have that inform their calculations for the models. Point being, there's a lot of infrastructure that underpins actual ML and AI applications. What I hope I've proved to you today a little bit is that there's no part of this that cannot be done with .NET if you really want to. So the key thing here is, for common purposes, is going to be how well .NET plays with any of the cloud providers. In this case, you get VS Code for free in Codespaces. I've talked to some businesses that actually do this, that have polyglot notebooks running in Codespaces in GitHub, and various members of their team can go and interact as you've seen me do today. AWS Sagemaker. Sagemaker, you can install a Jupyter kernel, which I'll show you in a moment. However, I've added this little bit recently because as of December, it turns out AWS are also moving towards a thing called SageMaker Studio. And that means they have basically promised multi-language authoring also. And they have started to use VS Code in their SageMaker Studio. So everything seems to be going the way of actually taking what .NET has done with with polyglot notebooks and using it as part of their own system. Azure as well have moved to using VS Code over Azure Data Studio. They're certainly moving that way anyway. So a lot of the Azure machine learning stuff you will find is actually going towards VS Code. SageMaker, and really any compute, can also be easily made to use .NET Interactive. In this case, this is the SageMaker example. You just create this as a lifecycle configuration, and it means when you start up your notebook, everything comes pre-installed, which is pretty neat. It's really not that many lines of code. And in more complex examples, it works with Bedrock as well, if any of you are keen on using AWS Bedrock for LLMs or image generation, any of that kind of stuff. This is all stuff that works out of the box with SageMaker as well if you just use that lifecycle configuration. So I can start talking to LLMs, I can start training RAG pipelines, I can do all of those lovely things. This is what that kind of architecture might look like in AWS, for those of you who are AWS-minded. It's a complex sort of way, or it's sort of a rejigging of what it looked like on the Netflix diagram we were looking at before. But essentially, in the SageMaker pipeline, those are going to be notebooks scheduled on jobs again, and you're going to monitor the model. All of that will be set up, but again, you can do all of that with .NET Notebooks. However, the big problem, which I've been kind of skirting around a little bit, is we are where we are. Python got there first. Python got the market. And when you're going to be hiring analytics engineers, data scientists, data engineers, they're probably going to be proficient in Python and know the Python tooling really, really well. So on the off chance that your business is heavily Python-based, I don't want you to necessarily walk away from here going, this young guy stood up at NDC and told me .NET is great to use for everything. It's great in the right situation. It's all about trade-offs, as with everything in engineering. If you want to hire the best talent that know everything in the current field, you probably want Python notebooks or some way to use Python notebooks and use the tooling that comes along with it. However, if you've built your entire business around .NET and you're willing to invest time and money into changing your infrastructure a little bit so that everything is cohesive, you can go down that route. So it's kind of a trade-off of what you choose. I personally think that C# and .NET is not very difficult to transfer from with the way they built it. I've showed today a lot of the syntax and terminology is the same. It just changes a little bit. So it is an option, but it's something to think about. However, also, Python and .NET kind of exist together in this world now, right? What I showed earlier is that notebooks are multi-language. So you can take .NET, anything that comes out of .NET, plug it straight into Python as a variable, and then you've got the advantage of both worlds, which means that I can set up data. I can do something like complex data operations beforehand, before I touch a data frame, or any of the stuff that you might do in pandas, and I can use the pandas library for Python, or get my data analysts to use Python, and they can coexist together. In a wacky world, you can also interop between the two. There are libraries like CSnakes and PythonNet if you want to try, but I don't know why you do that, given that you've actually got the capability of using both in the same notebook. So that is also an option which might help smooth over the edges of potential friction. So like all good things in life, it depends. It depends kind of on your use case. Just to reiterate, I think that the cloud providers are going very much the way of multi-language notebooks, partly because of the work that the .NET team have done, which is great to see. But it does depend on your use case and whether or not you need the best people for the job or whether you can invest the time. So just to end, I hope that today you've walked away with something from this talk that you will use notebooks for. I find them really useful in my own work. I've done some pretty good work for my business using notebooks, and I hope I've given you a little window into that today. So please go and explore them. Please give them a try, whether or not it's ML, AI stuff for your business, whether or not it's little experiments for yourself, whether or not you're creating open source documentation. There's plenty of different ways to use notebooks. Thank you very much, everyone. I've been Alexander Hall. Anyone got any questions?